All right, let's dive into something that seems so simple, but is actually one of the biggest challenges in modern agriculture: teaching a robot how to pick a cherry. It sounds easy, right? But this little fruit is where biology, cutting edge robotics, and the entire future of our food supply all crash into each other. So, what's the big deal? Why is picking this one fruit such a massive headache for engineers? It's not just about seeing the cherry and grabbing it. Oh no. The real problems are hiding in plain sight, deep inside the biology and the very architecture of the tree itself. And figuring this out has led to two completely different and pretty fascinating solutions. So the first big hurdle has this really technical name: pedicel fruit retention force, PFRF. But all that really means is how tightly the stem is clinging to the fruit. A human picker just knows. They have that feel for how to twist and pull just right without damaging the little branch that's going to grow more cherries next year. A robot that just yanks it, it doesn't just ruin one cherry, it could wreck future harvests. And the second problem? It's the environment. For a robot's computer brain, a classic cherry orchard is an absolute nightmare. We're talking a three-dimensional jungle of leaves, branches, and fruit all tangled up and hiding behind each other. Trying to find and then actually reach one specific cherry in all that chaos is unbelievably hard. And this right here, this puts that chaos into numbers. Occlusion rate is just a fancy way of saying what percentage of the fruit is hidden from the robot's camera. In a traditional 3D tree, it's over 40%. Almost half the fruit is invisible. But in a modern 2D tree, look at that. It's less than 10%. And that single difference, well, that changes everything. So, faced with all these challenges, the industry didn't come up with one single magic bullet. Instead, it's split. It's creating this great divide, a fork in the road for how we're going to harvest cherries from now on. And here are those two paths side by side. Path one is the stem-free revolution. This is all about the domestic, grab-and-go snacking market. The goal is pure volume and speed using these big mechanical shakers. Path two is the robot-ready orchard. This is for the fancy export market. It's all about precision, perfection, and quality, using advanced robots. But it means you need a totally new kind of tree. Okay, let's dig into path one first. This isn't some pie-in-the-sky idea for the future. This is a real-world solution that's being driven by a crisis that's happening right now. This quote from one of the sources, man, it says it all. For growers, especially in places like Oregon, automation isn't about pinching pennies anymore. It's about basic survival. When you literally don't have enough people to pick the fruit off the trees, you have to find another way, even if it means changing the cherry itself. So the process is this really clever mix of chemistry and just brute force. First, they spray the orchard with something called Ethifon. It basically signals to the fruit that it's time to loosen its grip. It weakens that PFRF we talked about. Then, a machine just rolls through and shakes the entire trellis system, and all the cherries just fall onto a conveyor belt. It's fast, it's efficient, and you harvest a crazy amount of fruit all at once. Now, I know exactly what you're thinking. For our whole lives, we've been told that a bright green stem is the #1 sign of a fresh cherry. So if these machines are just shaking them all off, doesn't that mean they're lower quality? Well, the actual research might surprise you. Yeah, check this out. An Oregon State University study actually found people had a greater overall liking for the stem-free cherries. And get this, they can actually have a better shelf life because the stem isn't there slowly pulling moisture out. Plus, you don't have those sharp stems poking and damaging all the other cherries in the package. So the industry is just leaning into it, rebranding them as convenient, snack-ready fruit. It's brilliant. And here's the real reason this path is taking off so fast. Speed can get through 50 to 100 times more cherries than a single robotic arm could. The economics of that are just impossible to argue with. All right, so now let's switch gears and look at path two. This is the high-tech, long-game solution. This is for that premium export market, where the customer expects and will pay for a perfect-looking cherry with a beautiful green stem still attached. And here is the most radical idea in this whole story. The solution isn't just about engineering a more sophisticated robot. It's about re-engineering the tree itself, biologically, to make it simple enough for the robots we have today. And they do this with a growing system called upright fruiting offshoots, or UFO for short. You essentially train the trees to grow completely flat, almost like a grapevine against a trellis. It creates what they call a fruiting wall. This totally gets rid of that chaotic 3D jungle and just presents all the fruit to the robot on a single, easy-to-scan, two-dimensional plane. And this table just shows you how dramatic that difference is. The old way, the central leader system, you've got that 40+% occlusion rate. Robotic viability? Basically zero. Forget it. But the UFO system? It's the new gold standard. Minimal occlusion, high viability. If you're planting a new orchard, this is how you're doing it. And of course, companies are lining up to build the robots for these new super orchards. You've got companies like Tevel Aerobotics using these little tethered drones that just fly up and down the fruiting wall. Then you have Advanced Farm, which was bought by CNH, using these soft robotic arms that gently vacuum onto the cherry and give it a little twist. You know, the business side of this is also maturing in a really interesting way. A lot of the early startups in this space, they kind of failed. They became these zombie companies. But their technology, their patents, that stuff was valuable. So these huge agricultural giants like CNH Industrial just came in, scooped up the tech, and now they have the money and the global network to actually scale these solutions. That's a huge sign the industry is getting serious. So, if we put all the pieces together, what does the next decade actually look like? Well, this isn't going to happen overnight. It's going to be a phased transition. For the next couple of years, you can expect this STEM-free pivot to really take hold, with mechanical shakers pretty much dominating the domestic market. Then we'll shift into what you could call a hybrid era, where those expensive, high-tech robots start showing up in those elite two-day orchards for the export markets. And then, probably by 2030 and beyond, automation will just start to become a standard, normal part of how you grow cherries. So what does all this mean for you, when you walk into the grocery store? Well, you're going to start seeing two very clear categories of cherries, those affordable, easy-to-eat snack-ready bags, and then the premium stem-on clamshells. The upside is this should lead to a much more reliable and consistent supply of cherries for everyone. But more importantly, this is really the opening chapter in a massive shift in how we engineer our food from the ground up. And that leaves us with one final, kind of mind-blowing thought. We have fundamentally redesigned a living thing to fit the limits of a machine. The cherry is just the beginning. The real question is, what food is next?